Good afternoon. My name is Irene Ayala, and I am going to explain now the paper that says photocatalytic degradation of bisphenol A on BiOI nanostructured films under visible LED light irradiation. This work was published in the Journal of Photochemistry and Photobiology A Chemistry, and it was published on May 25th from 2022. This paper was authorized by Michael Suarez Chamba, Damián Tubo Guamán, and Miguel Quispe, and Miguel Herrera Robledo. They come in from the Universidad Regional Amazónica ICAM in Muyuna Road, en Napo, Ecuador, and Carla Bisuete and Alexis Debut from the Centro de Nanociencia y Nanotecnología from the University de las Fuerzas Armadas ESPE. This sitting in Sangolquí, Ecuador. Now, talking about the abstract, and I am going to say this in Spanish in order for us to understand better. This paper is about, por primera vez se prepararon películas de oxiduro de bismuto, abreviado BiOI, mediante el método capa a capa. Esto es layer by layer, en inglés, utilizando microestructuras de BiOI en polvo, sintetizadas previamente por un método solvotérmico. Las películas de BiOI y las muestras de polvo se caracterizaron por difracción de rayos X, microscopía electrónica de barrido, microscopía electrónica de transmisión, espectroscopía de rayos X de energía dispersiva y espectroscopía de reflectancia difusa UV-Vis. La composición química y la morfología de las microestructuras de BiOI en polvo no se vieron afectadas por el proceso de deposición. Además, se evaluó la actividad fotocatalítica de las películas del oxiduro de bismuto preparadas y de las muestras en polvo en la degradación de bisfenol A bajo la irradiación de la luz blanca LED. Esta película de oxiduro de bismuto estaba compuesta por una capa en polvo en la degradación de bisfenol A bajo la radiación de la luz blanca LED. Y esto dio como resultado las microesferas de aspecto inferior y mostró la mayor actividad fotocatalítica. Entonces, la película compuesta por una sola capa de oxiduro de bismuto fue la mejor para este estudio de la actividad fotocatalítica, en comparación con otras muestras compuestas por 3 y por 5 capas. Las razones probables del mayor rendimiento fotocatalítico de este oxiduro de bismuto en una sola capa puede estar relacionada con su mayor área superficial, por las características morfológicas y por la geometría fractal. Estos resultados obtenidos en este trabajo demuestran que el método de layer by layer o método capa a capa puede ser una técnica adecuada para fabricar películas de oxiduro de bismuto con propiedades fotocatalíticas para el tratamiento de aguas. Las keywords, and I am going to say that in English again, are photocatalysis, layer by layer, BiOI immobilization, and bisphenol A. The key points of the introduction section is that water pollution by endocrine disruptor compounds that abbreviated by ADCs is a global concern due to the harmful effects on human health and aquatic life. 2 is that bisphenol A is widely used this is an endocrine disruptor compound that is found in plastics and epoxy resins. So this is a long-lasting harmful effect and has this effect on the environment. 3 is that the advanced oxidation processes like photocatalysis are being explored by the efficient removal of EDCs like BPA from water bodies. Then we have the bismuth oxyiodide that abbreviated as BiOI. Nanostructures and films are promising for water treatment due to their excellent electronic and optical properties. Finally, we have that the photocatalytic activity of BiOI films under visible LED light can offer a cost-effective and eco-friendly solution for water treatment. Then, the objectives of this study is to synthesize the the bismuth oxide flower-like microspheres via a solvothermal method. Second, to prepare the BiOI films on glass via a layer-layer deposition method and using the ACE-synthesized BiOI flower-like microspheres. Third is to characterize the structure and optical properties of powdery BiOI microspheres and BiOI films. This using a suitable instrumental analysis techniques. And finally, the fourth objective of this study is to evaluate the photocatalytic performance of BiOI films into the degradation of bisphenol A and their white light radiation. Then, as the key points of the materials and method section, we must emphasize on the analytical instruments and automation and control. So for this study, the barium sulfate was employed as a standard for the UV-based diffuse reflectance measurements. Then we have that bisphenol A was used as a model pollutant. Then we have that the BiOI microspheres were synthesized by a modified solvothermal method. This was reported by Mira and co-workers, and in this procedure, they used sonication combined with stirring of reactants, and this was transferred into a Teflon line autoclave. This was heated in an oven and then it was cooled. Then after that, the vacuum filtration was employed in the final BiOI product, and this was dried. Later, the BiOI microspheres were deposited on glass slides employing the layer-by-layer method. Then, these BiOI as a powder and film were characterized by X-ray diffraction, and this was done to evaluate the crystalline structure of the particles. Then the morphology of the powder and films was observed by scanning electron microscopy and the scan Mira 3 scanning electron microscope. After that, the hydrodynamic diameter of the particles as powders was measured by dynamic light scattering using an LB55 nanoparticle size analyzer. After that, the microstructure of the powders was observed by transmission electron microscopy. This is abbreviated as TEM. After that, the elemental composition of the powders and films was analyzed by the energy dispersive X-ray spectroscopy. This abbreviated as EDS. Then, another study was done. So, the visible light response of BiOI microspheres was investigated by the UVBs. This in the mode of diffuse reflectance spectroscopy. This is abbreviated as DRS. After that, we had that the fractal dimension of the BiOI films was calculated in order to analyze the relationship between the topography of the surface, the distribution, and also the aggregation patterns, and with this study, the photocatalytic activity. So, for this purpose, the same images were studied, and also the fractal dimension was calculated from the binary images. So they transform the same images into binary images in order to do this study. Finally, as the purpose of this study is to study the photocatalytic activity of these films and microspheres, and a study with the bisphenol A, which is a common pollutant found in water. So the photocatalytic activity of BiOI as films and powder was evaluated in the degradation of BPA in aqueous solution under visible light. So these experiments were performed with a photoreactor, and this was equipped with two fans, a 500 milliliters beaker, which was 6 centimeters in height, a stirring plate, and one white light LED lamp. And it was in the mode of 6000 K daylight, which is 100 to 200 volts, and this was placed in a 26 centimeter from the beaker. So this is the first part of the analysis of this paper, which studies the photocatalytic activity of these films. This was all for now, and thank you for seeing. This study of the results and the discussion section and the conclusions will be studied later on. Thank you so much for your attention and have a great rest of your day.